Good morning, everyone. First and foremost, I would like to thank Department of Physics of Namchi Government College and Sikkim University for providing this platform to explain the concept on such topic provided by our respected teacher, Dr. C.P. Khatiwara. Myself, Ranjit Chetri, roll number is 19 NSO 121, and my given topic is laser. Now, before starting laser, we should know what is monochromatic light and what is meant by coherent source of light. First of all, let us see monochromatic light. Suppose we are considering a wave and this is the wavelength, which is denoted by lambda. As we know, this is mono means single and chromatic means color, which means same color or same wavelength. So this type of light rays is called monochromatic light, or the source is called monochromatic source of light. Suppose we have this three wave, this suppose we have this three wave. In this three wave we have same wavelength, that means lambda is same. That's why we can say that this is monochromatic source of light. But we can see that the phase is not same. So we have a second term which is meant by dot. Coherence. Coherent means if the waves are traveling with the same phase or no phase difference, then we can say that this is a coherent source of light. So for coherence, we should first have monochromatic source of light. So if we have a monochromatic source of light, means lambda is same. Let us consider again the three wave. And they are traveling with the same phase. Then this source of light is known as monochromatic source of light. That means lambda is same and monochromatic source of light. And we can see that the phase is also same. So this is monochromatic and coherent source of light. Now let us see the other source of light here. Now the first source we have considered is let's take this three wave again. These are the different phases. Now if we consider this three wave, all these three wave having different wavelength is different. So here wavelength is different, as well as the phase is also different. As the phase is also not same, means we can say that this is ordinary source of light. This is ordinary source of light. So let us take some example of ordinary source of light. Example of ordinary source of light is the light coming from the candle or light coming from the sun is an example of ordinary source of light. Then we will take the second diagram. In this second diagram, we are taking the three wave. Then in this second diagram, if we observe the wavelength, all these three wave have same wavelength. When there is same wavelength, we can say this is a monochromatic source of light. Monochromatic. But if you observe the phase is different. The three waves, difference between the three waves means that this is monochromatic but incoherent source of light. Now, looking at the third diagram, let me draw. Now, looking at the third diagram, now again all the three waves are traveling with the same phase as well as their wavelength is also same, means this is monochromatic and coherent source of light. Now, the example of monochromatic and coherent source of light is laser. Laser is highly monochromatic and highly coherent source of light. Now let us see the long form of laser. Laser is the light amplification by stimulated emission of radiation. Laser was discovered by T.H. Meinman in the year 1960. And the first discovered laser was ruby laser, which was 3-level dimension system. Ruby laser. Now we'll see the properties of laser. First properties is highly monochromatic. Highly monochromatic means there is only one wavelength, but the wavelength range of laser is from X-ray to microwave region of spectrum. Start. Then the second properties is highly coherent. Laser is highly coherent means they travel with the same phase. Now third we have highly directional. Highly directional. Laser is highly directional means the divergence is very small. That's why it travels a long distance, and that's why there is a huge number of applications. But now we have some important definitions of laser. The first definition we'll see is excitation. Excitation is the process of transfer of particles from lower energy state to the higher energy state. Let us consider two energy level system. This is E1 ground state, and this is E2 excited state. Suppose the first energy level is E1. Let us say that it is a ground state and E2 is the excited state. Here the ground level is lower energy level and excited means higher energy level. We know particle prefers to stay in the ground energy level because the ground energy level is more stable than the excited state. Now if we apply some amount of energy to the particles, and in this energy is exactly equal to the energy difference between the two energy level. Suppose the photon of energy actually equals to E2 minus E1 is applied to the given particle which is present in the ground energy level. So this particle will absorb the energy and jump into the excited state. So we will say that the particle is excited and the process is known as excitation. Now the second one is lifetime. Lifetime means time spent by the particle in the excited state. Now in the first step we are considering a particle is in now excited state. E1 ground state, and this is the excited state. particle in the excited state. So the particle will absorb the energy and it will jump into the excited state. Now the particle will spend some time in the excited state, so that time is called lifetime of a particle. So generally lifetime of a particle is 10 to the power minus 8 second of hydrogen atom. Now the third important definition of laser is metastable state. Metastable state is the lifetime of a particle in excited state is greater than 10 to the power minus 8 second. Such an excited state is known as metastable state. We know that lifetime of a particle in excited state is 10 raised to 10 to the power minus 8 second. Let us consider two energy levels again, E1 and E2. E1 and E2. Now the particles will absorb some amount of energy and jump into the excited state. This particle will spend some time in the excited state, but sometime this will go up. But the general time of the particle in the excited state is 10 raised to 10 to the power minus 8 second. But if the particle is spending more than 10 raised 10 to the power minus 8 second in the excited state, then that excited state is known as metastable state. Now the last one we have active medium. The medium in which laser action take place is called as active medium. Active medium can be solid, liquid and a gas. Let us take the example of helium and neon. In this case of helium and neon laser, active medium is neon laser. Because the role of helium is only used to stimulate the neon atom. But if we will not get actual laser beam from the helium atom, so helium is only there to support neon, to excite the neon. Now let us see the uses of laser beam. First uses of laser is laser beam can be used in 3-dimensional image of object. First uses of laser beam is in the use of 3-dimensional image of object. Now the second use is laser can be used to destroy. It is used to destroy kidney stone. Third uses of laser light are used in optical fiber communication to send information over large distance with low losses. Fourth uses is used in nuclear fusion reaction as a potential energy source. And the last is used in cutting metals and other materials. That is glasses, diamond, etc. Laser have so many uses, but these are beneficent. So, laser is a device that emits electromagnetic radiation through a process of amplification based on stimulated emission of photons. The wavelength of laser light is extremely pure when compared to the other source of light, and all of the protons that make up the laser beam have a fixed phase relationship with respect to the one another. Laser is a powerful source of light having extraordinary properties which are not found in normal light source like tungsten lamp, mercury lamp, etc. The unique properties of laser is that its light wave travel very long distance with very little divergence. Thank you.